Hello students, today we will be studying about descriptive statistics. As the word suggests, it, it is the statistics which describes the data. Now we start with raw data. Suppose you have data of rainfall for 6 months for a weather station. This is known as raw data and we cannot use it directly. But you need to summarize it so that you understand it a bit more. And once you have certain graphical presentation like a bar chart or any other method, then it gives you a better explanation. So therefore descriptive statistics is describing the data and you can summarize the data and present it so that people can follow that data. So for suppose we have an example like this, that is you have minimum temperatures in the month of February and you have 4 weeks data. So this data does not tell us anything much about the weather or about the climatic conditions, but when we apply descriptive statistics, it is easy to understand. So here what are we going to do? We are going to find out the average and we are going to find out the range. The range is the difference between the maximum and the minimum. Now minimum temperature is 16 degrees and maximum is 24 degrees during this month. So the range of temperature is 24 minus 8, 16, that is 8 degrees. Now there are two methods of statistical measures which we use. One is based on location and the other on dispersion. Now the location methods include mean, median and mode, and the methods of dispersion are range, variance and standard deviation. So the mean, median and mode are also known as measures of central tendency. Now let us understand mean. Now mean is the measure where data is focused. It is also called as the average value and it is the most commonly used method. It provides a fairly accurate estimate but mainly for symmetrical or uniform distributions. Whereas if you look at ungrouped data in this example, we can see here that the months, 12 months are given and the yield is given for these months for a particular crop. So firstly we have to find out the total or the sum, that is 797, and the number of months is 12. So the terms which are used is summation xi, that is the total observation summation, and the number of observations is small n. So in this example we can see that 797 divided by 12 will give us 66.4, that is the mean for ungrouped data. Now if we look at group data and we have rainfall for 50 days for a weather station, then we put it into classes with interval of 10 and we can say that 5 days the rainfall was between 20 and 30 millimeters, 10 days between 30 and 40 millimeters and so on. So firstly we have to find out what's the mid value of the class interval. So that is the obtained by uh, the two lower limit, that is 20, and upper limit 30 divided by 2. Then we get the mid value, that is 25. Now if we do it for all the classes, then we can find out from this table, that from this column, that 25, 35, 45, 55, 65, 75, 85, these are done by simply adding 10 to the earlier one, which is the class interval. Then we multiply this frequency, which we call as f, by x, which is a mid value, and we get these are the results of the fourth column. Now when we want to find out the mean for group data, we have to add the number of days, the frequency, which is equal to 50, which we call as summation f, and we have to add the last column, that is f into x, that which we call as summation f into x. Now the mean is summation f into x divided by summation f, in this case 2440 divided by 50. So the mean is 48.8. We'll do more problems so that we can understand them better. Then we move on to the next method, that is median. The data may be uneven or they may be outliers. Now a stray outlier of a high magnitude will throw a mean of the central mark. This means, like, suppose you have data of rainfall for 5 uh, data points, like it may be 5, then 10, 15, 20, and the last one may be 500. So 500 is very far away from the first value, that is 5. So the average will be around 100 plus. So this average of 120 or 117, whatever you get, will be representing the lower most value and the higher most value. So that is the meaning of outlier. So median in this case uh, is very robust. It is not affected by outliers. It is based on ranks. So it does not affected by these extreme values or outliers. So how do we calculate the median for ungrouped data? We have an example of people visiting a museum. So we have 18 data points and the ages of the people are there. Now here, as you can see, they are not arranged in a sequence. So first thing is we have to sort it based on ascending value. So we can see that the lowest age is 8 and the maximum age is 30 years. So how do we calculate the median age position? It is a positional average which we call as n plus 1 upon 2, where n is number of observations or number of positions. So that is 18. So 18 plus 1 divided by 2 is 9.5. So we have to look at the position. In the first column you can see 9.5 lies between 9 and 10. Now if this example had 17 positions, then it would be 17 plus 1 divided by 2, that is, it would have come exactly at the ninth position. But because we have 18 observations, we are doing 18 plus 1 divided by 2, that is 9.5. So it comes between the ninth and 10th position. Which are the ages when we sort them? They are 16 and 17 years, isn't it? So we have to add 16 plus 17 divided by 2, and 16.5 is the median age. We'll do more examples to understand it better. Now let us look at group data. Now people are visiting a museum and we have classified them based on the age interval. So between 20 to 25 there are 4 people, 25 to 39 people, and the maximum age group, as you can see, is 35 to 40 years, where 23 people have visited the museum. So this class, we have to look at this class more carefully, where the frequency is the highest. Now before that, what we have to do is we have to do a very simple thing. You cumulate, that means you add the first and the second and the third frequency. So this is how we do it. 4 plus 9 is 13. 13 plus 11 is 24. 24 plus 23, 47. 47 plus 18, 65. 65 plus 7, 72. 72 plus 5, 77. And 77 plus 3, 80. So which is the uh, median class with the highest frequency? It is between 35 and 40 years. Okay, so this is the class with the highest frequency, which we call as the median class. Now we have to understand these terms. LL means lower limit of median class, that is the between 35 and 40, the lower one is 35. N is the total number of the frequency, that is the summation of the number of people visiting the museum. CF is cumulative frequency of the previous class, and F is frequency of the median class and class interval width. So you can see in this problem 35 is the lower limit of the median class, which is given here. Then 80 is the total frequency. Then 24 is the cumulative frequency of the previous class. So the cumulative frequency of this class is 47. So we have to look at the previous class, that is 24. Then cumulative, the actual frequency of the median class is 23, and the class interval is 5. Okay. Now we look at the formula which is used. Median age is equal to LL plus n upon 2 minus CF divided by F into CI. So 35 plus 80 upon 2 minus 24 divided by 23 into 5. This gives us 38.47. With more examples, you will understand this very easily. Then we come to mode. Mode is the measure of highest occurring frequency, or it is the most frequently occurring number is the mode. And the term mode, which we in German we say Mode, it is used for fashion, the thing which is most commonly used. We use it for that we use the term fashion, and you can remember it that way, that is, it is typically used for the data which is occurring frequently. So multimodal distributions show the focus of multiple locations. So sometimes you may have 2 or 3 uh, locations for the highest frequency. Here we are taking the age of the champion who have secured medals, and we can see here 17 age is the maximum. So the mode is the frequently occurring age, so mode is 17. So for ungrouped data, simply you have to look at the value which is repeated the maximum, and that is the mode. Now, but for group data, where we are taking the example of rainfall again, and we have made certain classes, and we have found out the number of days of when this kind of rainfall is occurring, starting from the lowest 40 to 50, which is 4, and the highest class is 140 to 150, that is 6 days. Now the frequency is highest for where the rainfall is between 90 and 100 millimeters. So that is called as the modal class. So again we have to understand these terms. LL is lower limit of modal class, that is 90. Then we use the term delta 1 for modal class frequency minus previous class frequency. So we have to look at the frequency of the modal class, and we have to the previous class frequency we have to subtract it from this. Delta 2 is modal class frequency minus the next class frequency. So 90 is the lower limit. Okay. Then we are subtracting 29 minus 16, that is modal class frequency minus previous class, so that is 13, and we are subtracting the modal class frequency minus the next class frequency, that is 4. 29 minus 25 is 4, and the class interval is 10. 50 minus 40, that is 10. Now what is the formula for mode? How do you calculate it? That is lower limit plus delta 1 upon delta 1 plus delta 2 into class interval, which is in the in this example you can see 90 is the lower limit. Into bracket we have found out delta 1. Beforehand we have calculated it as 13. Then we have calculated delta 1 again 13 plus delta 2, which is 4, into 10. So this answer is 97.65. You can try it and calculate it yourself. So this is how we are trying to understand the location of central tendency for symmetric distribution where the mode, mean and median are equal. If it is uh, if mean is less than median, which is less than mode, it is skewed left, and which we call as negatively skewed. And when the mode is the highest followed by median and mean, we say it is positively skewed. Thank you.